Welcome to this Chapter 27 video, where I discuss locking the producer-consumer model using pthread condition variables. My name is John Jolly. Let's get started. So here I am in my console again. I've gone ahead and added some code to my threads function. Let's go ahead and take a look at that. So if you remember, originally in our threads, at line 12, we added this mutex. And we're still using the mutex to protect the particular data structure, but we're going to introduce something called a condition variable. Condition variable is something that is provided by the pthread library. The pthread library allows for these condition variables to signal one thread that an event has happened. So how do I implement this? Well, if I take a look, I still am locking the mutex and then going in and checking to see if free count is actually available, if there's free items available. If it's not, instead of doing an unlock followed by a lock, I actually call pthread condition wait. Pthread condition wait takes two parameters. It takes a reference to the condition variable, and it takes a reference to the mutex. It needs both of these because the pthread condition wait does three things for us. The first thing it does, all within this particular function, the first thing it does is it unlocks the mutex. The second thing it does is it puts itself into a scheduler queue that waits for this particular condition variable to receive a signal. When that signal is received, then the third thing can happen, which is the mutex is locked. So again, first, and let's go ahead and put a comment in here so that it makes sense. I'm going to go ahead. So there's three things that happen here. First, mutex is unlocked. Second, condition variable is, actually, let's not say condition variable. Let's second thread is added to a wait queue until a signal is received. And finally, once the signal is received, the third thing it does is the mutex is locked. All these three actions are handled by pthread condition wait. So when this pthread condition wait exits, the mutex is locked, and we can go ahead and perform the check of free count here. And if free count is actually greater than or equal to 1, then we can decrement it before we actually call the mutex unlock. Now, in this particular case, once we've figured out we have a free item, we haven't changed that line at all. Now we can go ahead and lock the mutex again and increment our item count and unlock our mutex. Now I don't use a signal here because I'm not waiting for another thread to modify this. I'm just simply coming in. I've added an item. This code has added an item. It has no choice. But once I've unlocked that mutex, I go ahead and I call pthread condition signal on the condition variable. Now remember up here that a thread is added to the wait queue until a signal is received. Well, this is where the signal is received from. When this signals the condition variable, it causes any other threads that may be waiting to go ahead and attempt to lock that particular mutex. And so in this particular case, I've actually told another thread, you may proceed, meaning that this thread isn't going to loop until a signal is received. Now, I'm only running two threads. I'm running a producer thread and I'm running a consumer thread. And in this consumer thread, I'm doing the same thing. So if you take a look at the consumer thread, I'm calling pthread condition wait on this particular condition, and I'm calling pthread condition signal to notify any threads that may be waiting. All right, so let's see how this works. So I'm going to go ahead and exit out of here. I'm going to go ahead and build my program, and let's run it. Now remember, this has timing code in it, so it should tell us how long. We have significantly increased our response time. We're running regularly 300 milliseconds now, which is definitely not a speed improvement. You'd think that I'd be improving speed by not spinning as much, but we are relying so much more on the operating system to do scheduling for us. So our context switching is rather heavy in this particular configuration. It's not the best option here. There's ways of trying to fix this, but at this point, if I take a look, I've gone ahead and recorded that on average, I'm running about 255 milliseconds, although it didn't seem that way. I've pretty much doubled my processing time from just simply having a mutex. So there is a second thing that I did here. If I go ahead and check out ProdCons version 4, and take a look at the changes. In this change, what I've done is I've actually taken the mutex and the condition and I've duplicated them. So instead of just a single mutex, I now have two mutexes. One for the items, for the item count variable, and one for the free variable. So I've actually separated both the mutexes and the condition variable to these two different types. So now, instead of just simply locking a general mutex, whenever I want to access free count, I lock the free mutex. Whenever I want to wait on the free count, I wait on the free condition. So you can see here that there's a condition and a mutex associated specifically with the variable of the critical section. Same thing here. If I want to lock the item mutex, if I'm modifying the item variable, I will lock the item mutex and unlock the item mutex, and then signal the item condition. Remember, the item condition is going to be this signal to the item condition is going to wake up a thread that wants to check the item count variable, which is right here. So again, the consumer is waiting for an item to come in. It locks the item variable, or it likes the item mutex, checks the item condition, and then eventually unlocks the item mutex. And you have the free mutex down here with the free condition. I do have to initialize all of these, the mutex as well as the conditions. I forgot to mention the condition initialization. But let's go ahead and see how this works. So I'm going to go ahead and make this. And we'll go ahead and run it. 300 milliseconds, 200 milliseconds, 250 milliseconds, 200 milliseconds, 160 milliseconds. And so you can see that we're getting a slightly better response time when we have two condition variables than we did with one condition variable. So in this particular case, I've shown how to use condition variables to perform the operations that we need to lock our critical section, but not spin. Instead, allow the operating system to add us to a wait queue so that we can be woken up whenever we should be checking the variable. This brings me to the end of this chapter 27 video where I introduce condition variables.